Hello everyone, my name is John Battle and this is my Aviation 430 Scenario 2 presentation. Alright, so first up is the scenario. So two friends and I are going to be flying from Minneapolis, Minnesota down to Dallas, Texas to watch the Vikings and the Cowboys play. One of my friends, he's a little nervous, and the other friend has a lot of questions about twin engine airplanes. So I want to make sure, just to reassure them, that I know all the ins and outs of my aircraft. So I'm going to go over with them single pilot resource management, some of the aircraft systems, and the emergency and recovery procedures. Alright, so first up is single pilot resource management, which is managing all resources available to the pilot to ensure a safe, successful outcome of the flight. We can use the PAVE checklist. For this example, I'm using the 5 Ps. I'll go through this with my passengers. Explain first the plan, so I can use the NW craft checklist, which is NOTAMs, weather, known ATC delays, runway lengths. I'm going to need to do this for every airport that I fly to. There'll be multiple stops due to fuel. Also need to know my alternates, fuel required, and takeoff and landing distances. Next up is the pilot. So for myself, I'm going to go through the I Am Safe checklist for illness, medications, stress, alcohol, fatigue, and emotions. And then the plane. So I want to make sure all of my maintenance records are good, everything's up to date, all the inspections are good, they won't be expiring while I'm gone. I want to make sure my GPS database is current for this flight, and if there's any in-op equipment, I want to check back with the MEL, make sure it's okay to fly. If I don't have an MEL, then I use the 8 tomato flames checklist. Next up, the passengers. So me and my passengers, we all have a common goal here. We want to get down to Dallas to watch the game. I can use them, since one of them will be sitting next to me, I can use them to help me do certain tasks in the plane, so I'll divvy some of these tasks out. Some of those tasks might be to watch for traffic. It's always good to have an extra set of eyes. And then maybe have them read off checklist items in case two tasks saturated. They can kind of help me out there. I want to help put them at ease, so I'm going to explain everything, all the emergencies and the engine out procedures, so that they know what to expect also if it does occur. Lastly is programming. So our GPS, I want to make sure I load the flight plan on the ground so I'm not messing with it in the air. And then if we have an autopilot system, I want to make sure it works. If it doesn't work, I want to make sure it's in op. Alright, so the first system I'm going to talk about are the engines. So we have two Lycoming engines producing 180 horsepower at 2,700 RPM. They are counter-rotating, so we do not have a critical engine in this airplane, even though most twin engines do. It's a 4-cylinder direct drive horizontally opposed engine. It has a wet sump oil system, which I just learned about this week. It's located underneath the engine. It has a maximum oil, can hold up to 8 quarts of oil. We want at least 6 quarts before we go fly, so I'll make sure that we have that. It's also a carbureted system. We can use the cowl flaps to cool the engine. It's pilot controlled. It has a dual ignition system, so we have magnetos. This helps provide more redundancy. It's a safer way to fly. It also helps burn the fuel mixture within the cylinders cleaner and more evenly. We have a max oil temp at 245 and CHT temp of 500, and our max oil pressure is 100 psi. All right, next up is the fuel system. So here we have our fuel schematic for the Beechcraft Duchess. We need at least 9 gallons of fuel before we take off. We'll have a lot more than that because we'll be flying a pretty long distance. It uses 100 low lead fuel with 103 gallon total capacity. Only 100 of that's usable, so that's split between the two engines. In order to bring the fuel from the fuel wing tanks into the engine, we have 2 engine-driven fuel pumps, and then 2 auxiliary fuel pumps, which are used for takeoff, landing, on start, in emergencies, and in case we need to change the fuel selector. We do have a cross-feed system, but that should only be used in emergency situations. All right, so the emergency checklist. In the unlikely case that we do have an emergency, we will refer to this checklist. I will brief my passengers beforehand, before we take off, on engine out procedures on takeoff. I'll ask them to assist if possible. If we do have an emergency, maybe they can help me read some of these checklist items and verify that I've done everything right. All right, the first procedure, emergency that I'm going to talk about today is a door open in flight. I chose this one because it's happened to me before. So the first thing we want to do is we want to reduce the airspeed to 85 knots, indicated airspeed. We want to make sure our cabin vents are closed and our storm windows are open. We want to leave the latches open until we can successfully latch the plane door shut. In the case where we can't get the door shut, we'll land and do it on the ground. Next up is prop overspeed. And prop overspeeds usually occur when there's a loss of oil pressure and the prop automatically feathers. So the first thing we want to do is bring the throttle down and check the oil pressure, make sure that it's not completely out of whack. We're going to reduce the prop control, reduce the airspeed, and we want to make sure it does not go over 2,700 RPM, which is our max RPM. If we can't fix the problem, we'll cut power to that engine. All right, the next emergency I'm going to talk about is an engine fire in flight. It's one of the worst case scenarios you can have in flying. So if we do have an engine fire in flight, the first thing we want to do is we want to cut the fuel from that engine. So we want to turn the fuel selector to off for the affected engine. We want to make sure our mixture is brought to idle cut off. Prop feathered, auxiliary fuel pump off, and we want to turn everything off, the magnetos, the alternator, everything to the affected engine. If the fire isn't put out, then we want to increase our airspeed to 140 knots to put out the fire, and we want to land as soon as possible. Say this happens in flight to us, and we have to do a single engine landing. Our procedures for that would be to secure the in-op engine, which we've already done because we had this in-flight fire, and we want to maintain a safe airspeed. So we want to stay above 85 knots. As we get closer to the airfield and we can assure that we're going to land, we want to lower the gear. On final approach, we want to stay above 85 knots until we can for sure make the field, and then we can put the flaps down and make a safe landing. All right, these are my sources, and thank you for watching.